Okay, so now let's look into Vieta's formulas. And I think this is one of the most important things, especially when it comes to AMC 10 and 12. It relates like the sum and product of the roots of a polynomial to its coefficients, and that's really key detail, an efficient way to solve a lot of problems. Oftentimes you sometimes can't like factor and things like that, and in those cases, Vietas comes really handy. And so for quadratics, we have if there's, so we're actually going to rewrite this as ax squared plus bx plus c is equal to 0. It has solutions r and s. Then technically, so when you factor it out, you have ax squared plus bx plus c is equal to a times x minus r times x minus s. And it'll be, let's rewrite this. It'll be ax squared plus bx plus c is equal to ax squared minus a times r plus s x plus ars. And what this gives us is that r plus s, r1 plus r2 is equal to negative b over a, and r1 times r2 is equal to c over a. And that should make sense because, well, if you look at let's look at the x squared plus ax plus b form, and say our original polynomial had capital AX squared plus BX plus C. And in that case, we get that setting A equal to 1, B equal to A and C equal to B, we get that x squared minus r plus s x plus rs. And so what this gives us is that in a general form for quadratics, the sum of the roots is equal to negative b over a, and the product of the roots is c over a. And for cubic polynomials, when we expand it out, we get that I'm assuming obviously the coefficient is 1 in this case, but similar rule applies. So a is equal to negative, the sum of the roots is equal to negative a. Sum of the product of two roots basically is b, and then c. Negative c is obviously the product of all three roots, and so on and so forth. So in a general case, for Vietas, we have a polynomial of this form, and you can write it in. So you can write it as a sub n times x minus r1 times x minus r2 times x minus so on and so forth times x minus rn. The general form for Vietas is that the sum of the roots is equal to the second coefficient, negative of second coefficient divided by the first coefficient, and the sum of, and then so on and so forth. It just keeps going. And for general, and for the end, the product of all roots, it's negative 1 to the power n times a0 over an. Generally, the ones that you need to know or focus on are actually this one, and this one anyway. In the middle ones are often like omitted because it makes the problem too complicated. But it's good to know that, for example, R1, R2, R3 plus R1, R2, R4 and so on and so forth till, Rn minus 2, Rn minus 1, Rn. That is equal to negative a sub n minus 1 divided by a sub n. So these kind of things are really useful to know. And with that, let's look into an example that applies this. So let a and b be the roots of x squared minus mx plus b plus 2, and let a plus 1 over b, and b plus 1 over a be the roots of x squared minus px plus q. So they're asking for q, and we know that q is basically the product of the roots. So that's a plus 1 over b times b plus 1 over a. And let's multiply this out. So we get ab plus 1 plus, what is it? B, or 1 again, plus a 1 over ab. So if you write this out, then it's ab plus 2 plus 1 over ab. And do we know AB? The thing is, we do, because this is the product of A and B, right? AB is equal to 2. That's what we get from the first relation. So all you have to do is just plug in AB equal to 2, and then you get that 2 plus 2 plus 1 over 2, which is 4.5, or 9 over 2. And so that was simple. That's our answer. So here, Vietas is really useful because, trying to, with so many unknowns, it's practically impossible to try to factor and find the actual values of A and B, but here there's no other way but to apply Vietas.